Mrs. Webber's Physics Adventure, Newton's Second Law of Motion. The clock struck 2:10 p.m., and Mrs. Webber strode into the classroom with her signature energy. Her bun was slightly askew, and she clutched a coffee cup with "I break for physics" emblazoned on the side.
All right, everyone. Settle in. Today, we are diving into Newton's second law of motion. By the time we are done, you'll all be physics geniuses, or at least good enough to make my cat look bad at math.
The students chuckled. Robbie, a boy notorious for his random interruptions, raised his hand immediately.
Yes, Robbie?
Does this involve apples falling on heads? Because if it does, I'm sitting in the back.
No apples today. That was Newton's first law. But don't worry, you'll still be amazed. And no one will leave here with a concussion, unless someone gets overly enthusiastic about science.
Mrs. Webber rolled in a cart loaded with textbooks, a spring scale, and a mysterious box labelled "Science Supplies Warning, May Cause Fun." One of the students, Emma, was curious and asked regarding contents of the box. Mrs. Webber said,
Patience, Emma. Science is all about suspense. And sometimes explosions. But for today, it's mostly suspense.
Mrs. Webber hooked the spring scale to the empty cart and wrote an equation on the board with exaggerated flair.
Now, we are going to use this cart to explore Newton's second law, force equals mass times acceleration. Or, for those who like their physics spicy, F equals m times a. Let's start simple. Who here thinks they are strong enough to pull this cart?
Liam, the class's self-proclaimed athlete, stood up and volunteered.
Great, but remember, this is science, not gym class. No pulling muscles, you'll need those for writing lab reports.
Liam grabbed the spring scale and pulled the empty cart across the floor with 1.5 newtons weight.
Excellent. Now let's add some mass. Robbie, hand me those thick textbooks.
Robbie groaned as he passed 3 thick volumes to Mrs. Webber.
Why are these heavier than my will to do homework?
Because knowledge is weighty, and apparently, so is your sense of humor. I will place some more books in the cart, and you can try pulling harder this time. It's 3 newtons. Go, Liam. Push harder. Fantastic. Did everyone notice what happened? Yes, Ethan, your turn.
Yeah, Liam's face turned more red than a stop sign. Womp womp womp.
True, ha ha. But more importantly, when we added mass, the force needed to move the cart doubled. That's Newton's second law in action. Now, what happens if we push harder, Robbie?
It goes faster. I think.
Exactly. And that, class, is why I don't push the grocery cart too hard at the store. I'd like to keep my kneecaps intact. Now, let's talk about where we see this law in real life. Who can give me an example?
"Cars!" shouted Emma.
Yes. When you press the gas pedal, the engine applies a force to the car. The lighter the car, the faster it accelerates. That's why race cars are super light, and why my minivan drives like it's towing a small planet.
"Football," added Liam.
Exactly. When you kick a ball, the harder you kick, the faster it flies, unless you miss, in which case the only thing accelerating is your embarrassment.
"Rocket launches," Chloe offered.
Absolutely. Rockets need massive force to lift their huge masses off the ground. Imagine trying to launch Robbie into space.
Why me?
Because you're the perfect test subject, lightweight, full of energy, and always reaching for the stars, metaphorically, anyway. And this isn't just about pushing carts or kicking soccer balls. Engineers are working on things like maglev trains that float above tracks. Imagine commuting to school in a train so fast you'd actually miss hearing me talk about physics. And scientists are even working on landing spacecraft on other planets using these principles. Maybe one day, one of you will design a ship to colonize Mars. Just promise me you'll name a crater after me.
All right, quiz time, Mrs. Webber announced, pulling out a stack of flashcards. Groans filled the room.
Oh, hush. It's a fun quiz. No calculators required, unless you plan to calculate how many snacks Robbie eats during recess.
It's 42, by the way. The answer's always 42.
Question 1. If I double the mass of an object, but keep the force the same, what happens to the acceleration?
Easy, said Olivia. It's halved.
Correct. And you didn't even Google it. Question 2. Name a real-life example of Newton's second law.
Throwing a baseball.
Perfect. Bonus points if you hit a window. Okay, just kidding. Don't do that. You're all officially smarter than my cat. Well done.
As the bell rang, Mrs. Webber called out, "Remember, kids, physics is everywhere, even in the way your sandwiches squish when you bite them." Robbie stopped in his tracks and said,
Wait, how is physics in sandwiches?
That's Newton's third law. For every bite you take, there's an equal and opposite squish.
The class burst into laughter as they fled out, and Mrs. Webber smiled, knowing she'd made another day of physics unforgettable.